Hello, and welcome to Astronomy 100. In previous segments, we've been talking about the origins of understanding and how astronomy of today, our basic understanding of the universe, is something that took a bit of time for us to figure out and to correctly understand the workings of our universe. In previous segments, we spent some time talking about the people who have led us to where we are today. We talked about how Aristotle was able to propose ideas to describe the appearance of the movements of the planets in the sky, and how he created the idea of geocentric motion, the belief that the Earth is the center of the universe, but the geocentrism, meaning Earth-centeredness of the universe, meant that everything goes around the Earth. Later, what we find is that Ptolemy comes along and is able to show that there's a few corrections that need to be made to this model, and he's able to describe the connection between the Earth and the Sun as it fits into this geocentric model. Later, we find that Aristotle is one who has an idea that withstands a very, very long period of time, but there are people who come along who are able to make suggestions of alternative ideas, and that's where Aristarchus came in, suggesting a heliocentric idea of perhaps the Sun being the center of the universe. And although this is a correct notion, it would be a notion that wouldn't be accepted for many, many centuries. Around the time of the Renaissance, we find that Copernicus comes along and is able to show how all of the ideas of heliocentrism could possibly be true, and he's able to mathematically explain how the Earth could be a planet in an orbit around the Sun, along with all the other planets in orbit around the Sun. We find that it is Tycho Brahe who offers up the all-important observations of the movements of the planets over a 20-year period while he is making observations of the sky in the latter part of the 15th century. And then what we find is that it is Kepler, Johannes Kepler, who comes along and explains the movements of these planets and, of course, comes up with what we today call Kepler's 3 laws of motion. In this segment, what we're going to do is concentrate on the very important person related to the history of astronomy, and that is, of course, Galileo. Galileo comes along and is able to make an observation of the universe that would forever change the way that we see the universe. He's able to do something that had not been done prior, and that is that not just to suggest a heliocentric model, where the Sun is the center of all things, and that the Earth is a planet, but to show proof, to show evidence that it could be that this heliocentric model is the correct interpretation of our universe. Now, Galileo lived in the second half of the 16th century in Italy, and he was somebody who was very much a man of the Renaissance. He was somebody who was part of the aristocracy of the age. He was somebody who was college educated. He was somebody who was very curious about the universe around him. But what made Galileo very special compared to some of the people that we've talked about to this point is that Galileo was somebody who strongly believed in the concept of the scientific method. Galileo's belief was to understand the universe is to basically provide evidence to support the claims that explain the universe. Making an explanation about a particular phenomenon is not good enough, but to have evidence to support that explanation was the correct way to proceed with science. And that is still the method that we use today, that we call, of course, the scientific method. Now, there's typically a misunderstanding about Galileo, or a claim that turns out not to be true, although is relatively important. Galileo is not the inventor of the telescope. But what Galileo does is he is somebody who makes vast improvements of the telescope. The telescope was invented in the year 1608, and it was invented by a Dutch lens maker. His name was Hans Lippershey. A year later, Galileo hears about this new device, this new invention of an optical instrument that allows you to see things around you in a way that you couldn't see them before. And in the pictures that you see here on the screen, on the left, here are actually 2 of Galileo's telescopes still in possession of a museum in Italy, still on display. And the basic idea of a telescope is actually quite simple. it had been known for years that if you take a piece of glass and if you shape that piece of glass to the proper shape, and if you have several of these lenses, as they're called, in the correct combination, when you look through these lenses, objects that are far away will seem closer, or objects that are small will seem larger, objects that are faint will seem brighter. And so Galileo is not the inventor of the telescope, but Galileo is the person who uses the telescope for astronomical purposes. When the telescope was first invented, it was really a device that was used for things on the Earth. It was used by the military to be able to see an invading army much further away than you previously could. It was used by the Navy to be able to see land at distances much greater than you previously could. It was used as an instrument, just as a novelty, to see things around you in a way that you couldn't see before. But Galileo was one of the first people to take the idea of the telescope and wonder and use this telescope to look at objects in the sky. He wondered, what would it look like if we could see things up above in a way that we previously couldn't? It may sound strange that nobody else really had the idea to do that, but the reason why is because for thousands of years, our belief system was that there was nothing to see up there, that the universe of the heavens was what you already see, that there was nothing more to learn, and that the motions of the objects of the sky had been long figured out by people like Aristotle and Ptolemy. But Galileo, of course, being the curious scientist that he was, decided that it was worth a look and to find out what the universe had to offer as seen through the telescope. So what I'm going to do is show you some of the more important discoveries that Galileo made with his primitive telescope and how these discoveries would eventually provide the actual observational evidence needed to support the heliocentric model and to forever make the geocentric model be a relic of the past. Now, the first thing that Galileo looks at with his telescope is the Milky Way. And the Milky Way is something that you can see without a telescope. If you go outside on a dark night from a dark location, it is this milky white band that appears to cross the sky. And without a telescope, it just simply looks like a fuzzy white river of light that crosses the sky. But as you can see in this photograph here, this is an all-sky photograph. If you have the ability to see the Milky Way through a telescope, what happens is you'll discover, as Galileo did, that all of these white patches, all of these white spots are actually countless numbers of stars. That the stars of the sky that you see with your eye are just a few of the stars that actually exist in our universe. So Galileo was able to figure out that the universe actually contains many, many more stars than people had previously thought. So you can imagine that if you lived in an era when you thought that there were just a few thousand stars that made up the universe, suddenly overnight discovering that there are millions, if not billions of stars in our universe. So this was a tremendous discovery that essentially made the universe feel much larger than had been previously thought. Now, the next thing that Galileo looks at with his telescope is the moon. And in a previous segment, we have spent some time talking about how Galileo's observations of the moon led us to a better understanding about the actual surface features of the moon as a physical body. And if you remember from that segment, we talked about how the moon is covered with countless numbers of holes. If you recall, we call those craters, the word that Galileo coins to describe them. Galileo describes the dark circular regions on the moon as lunar maria, these very smooth, dark places that turn out to be lava flows. You can see in this picture on the right, this is an actual photograph of one of the journals that Galileo was able to record his observations with. And you can see through watercolor, he was able to make some pretty good portrayals of what he was seeing through his telescope. Remember, there is no photography in the early part of the 17th century. Now, the next thing that Galileo points his telescope at is something that, of course, we need to refer to in a cautious way and describe in a cautious way, because if you were to use a telescope to look at the sun, this is something that you must do with skill and, of course, with the proper equipment. Whenever you look at the sun, even without a telescope, it is very dangerous, it is damaging to your eyes, and it's something you shouldn't do. If you use a telescope to look at the sun, it is even that much more damaging. The purpose of a telescope is to create a magnified view of what you're looking at, a brighter image of what you're looking at. And so looking at the sun through a telescope causes just instant damage to your eyes. So make sure you do not do it without the proper equipment. So you might be wondering, how did Galileo do this without hurting his eyes? So let me show you how he did this. Galileo used a technique that we often still use today that is called the projection method. And in this technique, what you do is you take the telescope and you aim it at the sun. You allow the light from the sun to pass through the telescope, but rather than putting your eye up to the back end of the telescope where you normally do, you allow the light to simply exit the telescope. And a couple feet away from the telescope, you have the ability to project that image onto a piece of paper or anything that you want to project it on. And in doing so, what you will do is project a very, very nice and sharp image of what you see through the telescope. So by using the projection method, Galileo was able to see the surface of the sun in a way that is safe. And let me show you a picture of one of his drawings. What he would do is he would lay a sheet of paper, if you will, over the projection, and then he would trace onto that sheet of paper whatever it was that was being projected. And you can see in this picture here that Galileo recorded features on the surface of the sun that had not been seen prior to the invention of the telescope. Galileo, in essence, discovers something about the sun that had never been seen before. And if we switch to this photograph up here, you can see it much better. These are what we call sunspots. And these sunspots are these dark blemishes that you see on the surface of the sun. And almost any day, if you were to go outside, you will find these dark blemishes. In the early years of the 17th century, nobody really had known of these dark spots. And of course, Galileo doesn't really know what causes them. Today, we understand that these dark spots, or these sunspots, are places where the magnetic field of the sun has been twisted and distorted, and the light has a difficult time making it through the surface in these places, and so therefore these parts are a little bit cooler than the surroundings. It is something that took many years for us to figure out. But in the era of Galileo, the fact that the sun has these dark blemishes ran contrary to the assumptions of many, many centuries leading up to that point. If you recall in a previous segment, we talked about how Ptolemy assumed that all objects in the universe were perfect and that they never changed. And here is Galileo discovering that one of the most critical items in the universe, the sun, one of the most important celestial bodies, is definitely not perfect. It has these dark spots. The other thing that Galileo was able to figure out is that if you were to look at the sun and watch it day after day after day, recording these dark spots, what you would quickly find out is that these dark sunspots appear to move. And in this particular animation, this is about a 5-day period of images of the sun that are put together as a movie, if you will. And what you'll notice is that over this period of time, the sunspots all collectively seem to move across the face of the sun. And as they're moving across the face of the sun, you'll notice that they change over time. Well, Galileo is a little bit confused by this, but when he thinks about it and studies the movement of these sunspots, he realizes that it is not the sunspots themselves that are moving, but it's actually that the sun as a body is physically rotating. So what Galileo discovers is that the sun is a rotating body, and that if you watch the sunspots for a long enough period of time, you'll quickly find out that the sun has about a 30-day rotation to it. So 30 days go by and you'll watch any one of these sunspots work its way all the way back behind and come back to where it started from. So in Galileo's mind, if the most significant celestial body of our universe, the sun, is a rotating body, then why can't the Earth be a rotating body? If you recall, up until that point, the people of the past just simply could not accept that the Earth is a rotating body. And so here is Galileo showing that this is indeed possible, that the sun rotates on its axis, and so there's no reason to doubt that the Earth could also rotate. And so this was a critical step in at least providing observations that some of the ideas of geocentrism were just simply not true, that these assumptions were just that, were just assumptions. And through observational evidence, he was able to prove that some of these ideas were simply wrong. Now, in the next segment, we'll talk about how some of the other observations that Galileo made with his telescope turn out to be the most critical of them all to finally prove that the heliocentric model is correct and that the geocentric model that had been around for thousands of years just is simply wrong, and it is something that can be relegated to the past. I hope you'll join me.